Hello everyone, in this video tutorial, I will run Yolov8 on Windows. So first we need to set up environment for Yolov8 and install required libraries. I am using Anaconda Navigator. So I have opened Anaconda prompt and so I will create a new environment with Python version 3.9. So before I create the new environment, let me show you the folder where I have the input image for a demo video to test the Yolov8 model. So this is the input image and the demo video, of course, which I will use to test the efficiency of Yolov8 model. So first of all, I will redirect to the folder where I have this input image and video. Now I will create a new environment on the create -n Yolov8 lecture series will be the name of my environment. You can choose as per your choice. So you can choose any name for your environment and Python version as 3.9. Now I will click on enter. So it will create a new environment. Just click Y. It might take few minutes, so please bear with me. Now I will activate the YOLO environment which I have created. On the activate Yolov8 lecture series is the name of my environment. So I am activating it. Okay, so I have activated my environment. After activating the environment, I will install Ultralytics. So for this, I will write pip install Ultralytics is equal to 8.0.0 and click on enter. So Yolov8 can be implemented in two ways. One way is to clone the GitHub repo, or other way is to install Ultralytics. So prior versions of YOLO don't have their official package. So Yolov8 is the first version of YOLO which has its own package, which so Yolov8 can be implemented by just writing pip install Ultralytics. So it's very easy and simple. So I write Python over here and see if I have installed torch, import torch. Is this module available or not? Let's see. Okay, so this module is available, but in case if this module is not available, so how to install it? Let me show you over here as well. So you just need to go to the PyTorch website and click on get started. And here you will select PyTorch build stable. Your operating system is Windows, but if it is Mac, you can select Mac. If it is Linux, you can select Linux. Then package will be pip. Language will be Python, and I don't have GPU available. So if I have to install this package, I will select CPU. But if you have GPU available, you just need to go click here, copy, and you just need to go to Anaconda prompt and just exit over here and just write this. But as I don't have CUDA, so it will definitely give error because I don't have a GPU available. Okay. So next, I will go and run Yolov8 for object detection. So let's run Yolov8 for the object detection. So to run Yolov8 for object detection, write YOLO toss is equal to detect, mod is equal to predict, model is equal to YOLO v8 and .pt, source is equal to image. The name of our input image which have saved in the folder is image.jpg, and just run it and see what the results do we get. So it might take few seconds or minute. So let's wait and see what the results do we get. So it's downloading the pre-trained model over here. So the pre-trained model is downloaded. Okay, so image.jpg is not defined. Sorry, the name of my input image was image1.jpg. So just correcting it. So you can see that our results are saved in run detection predict2, and our model was able to detect 10 persons, 1 bus, 2 traffic light, 2 backpacks, and 2 handbags in the image. So let's see the results, and then we will run object detection on a video as well. So here is the input image which I have passed, and this is my model which was downloaded when we run the script, and here runs folder in which my output image is saved. So let's check the output image. So this is my output image. You can see that the model was working very fine. It is able to detect the traffic light, persons, and back, and very well. So the results are quite fine. So now let's test this model on a demo video. So as I don't have a GPU available, so the processing will be a bit slow. So let's wait and see the result on a demo video as well. So to run on a demo video, I will just change the source as demo.mp4 and just run. Demo.mp4 is the name of my input video on which I want to perform the detection. So it might take few more seconds. So let's wait and see. So you can see that as I don't have a GPU available, I'm using CPU. So the detections are a bit slow. So I have already run this script. So let me show you the output which I got. So this is the output demo video which I was getting. You can see that the results were very fine. You can see that the model was able to detect the cars, track. There is a wrong detection of truck, but overall the results were fine. Like the model was able to detect the cars, truck, and so on. So now we will move towards the Anaconda prompt and let's explore some further things. We can set the confidence value as per our choice. If we want our detection shouldn't be below a certain confidence, so we can set the value of confidence as per our requirements. So here, for example, I am setting the confidence value as 0.8. So the detections below the confidence 0.8 will not be appearing. So let's set the confidence as 0.8 and click on run and see what results do we get. So our output is saved in runs detect prediction 5. Let's see what the output do we get. Okay. Just move towards the folder. Here is the prediction 5 folder and here is our output. So let's see what is different from the previous one over here. So now you can see that few detections are missing. No, not we are out. For example, we are unable to detect the bus. We are unable to detect the traffic light. We are unable to detect these two persons as well. Okay. The reason why we cannot detect these two persons because we have set the confidence value limit at 0.8. So the model will not detect those in. The model will not do the detections or detections will not be printed which have a confidence value less than 0.8. So only those detections will be printed on the image which have a confidence value above 0.8. Okay, so let's explore some other things as well. So other thing is that if we want to save the bounding box coordinates or want to save the bounding box option, so we can simply write save dash text is equal to true. So this will save the bounding box information. Let me just click over here. You can see the bounding box coordinates information will be saved in a text file if we set save dash text is equal to true. So our output is saving prediction 6 labels folder. Let's see what output do we get. So I'm just going to prediction 6 folder. And if you see labels, so here you will save image file. So let me show you this image file. So now in this, you can see that these are our detections coordinates. For example, 26 represents the class number. These are to the x1, y1 coordinates, the top left, and these two are the bottom right coordinates of the bounding box. So for each class, we have the coordinates, and this is the class number. This is the top left coordinates, and these two are the top left coordinates, and these two are the bottom right coordinates. So in this way, we have the coordinates for each of the object in our image, detected object in the image. So now let's see further new things. So if we want to crop all the detected, for example, we have detected 5 persons in the image. So I want to crop all the detected persons in the image. We can also do this by just writing save dash crop is equal to true. So this will save all the detected objects in the image separately. Let's see what results do we get. Then I will show you the results as well. So the results are saved in run detect predict 7 labels folder. Let's see the results. So click on crops. So let me see what. So you can see over here. Let me open this image. So you can see that only this bus is detected, like you cannot see our other objects. So the frame in which we have the bus, we have only this frame as separately stored. So let's see other objects as well. Okay. Let's open this image and say, for example, this bounding box or this is also separately saved. So using crop touch image, we can save each of the bounding box separately or each of the detected image separately. Okay, let's explore some new things further. Okay, so now you can see that we can also remove labels or hide labels or hide the confidence value as well. So to do this, I will just write hide dash labels is equal to true and hide dash confidence is equal to true. So this will hide the labels and confidence value from the detected objects in the image or the bounding boxes. As well, it will also hide the objects in the, it will also hide the labels and the confidence values in the videos as well. So let me show you in the result detects our output is say predicted. So if I show you this image, so now you can see that we don't have any confidence value or the label value over here. So they are missing. So by setting high dash label true and high dash confidence true, hide the confidence value as well as the label as well. So now let's move towards the segmentation part and see what do we can implement over there as well. So to implement the segmentation, you just need to do one thing, or you can run the detection on a live webcam as well. You just need to change source as 0, and you can test it on live webcam as well by changing source to 0. So now just to implement segmentation toss, you will need to do one thing only by changing toss is equal to segment. Okay, and just click and just you need to change the model as dash HCG. So HCG represents segmentation, while for classification we write dash CLS. Okay, while for simple detection just write Yolov8 and .pt. So just click on enter now and see what results do we get. So it might take a few seconds. So let's wait and see what results we are getting. Okay, so our results are saved in run segment predict folder. So let's go to this folder and see what results do we get over here. Okay. So let me move towards this folder over here. So let's open this. So this is our output image. Let's see this image, what results we are getting over here. So you can see that we are able to implement detection as well as segmentation as well. So the bus is being segmented as green. So here we are implementing semantic segmentation, while the persons have a mask of maroon, while backpack has the mask of yellow. So this is basically semantic segmentation, like same object have the same mask, while different object have the different mask and the different color of the bounding box. So let's implement some further things over here. So in the segmentation as well, we can hide label as well as the confidence value. Let me show you how you can do this. So here you just write hide dash labels is equal to true and hide dash confidence is equal to true. Let's click on this. So it might take few seconds to run. Okay, so I think that I have not written the spelling of confidence. There is a mistake over there. Let me see. Okay, so I have written, okay. So there is a space issue. Let me correct it. So please, while implementing, please make sure that there is no such space and click on enter now and see what the results do we get here. It might take a few seconds. Okay. So the results are saved in run segment prediction. So let's move towards there and see what results do we get. So now you can see that our output image does not contain a label and a confidence value. So this is the output result. Neither we have the label or the confidence value. So now, if we want to show the output in real time, what we need to was just add one thing. Just add show is equal to true. It will display your output in real time, but it will be appear only for 1 millisecond. Let's see. So just press enter and see. It might take few seconds to execute. So wait for few seconds until it executes. Okay. So it will appear only for 1 millisecond, as you can see. And our output is saved in runs predict 4. And let me show you the output. Okay. So it's this saved in runs predict 4. So here is our output. You can see over here. Just opening it now. So this is our output. You can see that by writing show is equal to 2, we are able to display the output in real time for 1 millisecond, and output is saved in the folder as well. So let's move forward now. So now to convert our Yolov8 model into Onyx format, I will write YOLO mod is equal to export, toss is equal to detect if we have a detection model. In the case of segmentation, we will write segment, and in the case of classification, we will write CLS and model Yolov8 n.pt, and format is equal to Onyx. So after writing this, click on enter and let's wait. It might take few seconds for the execution. So let's wait and see how our model is converted into Onyx format. We are able to convert our Yolov8 model into .onyx format. So it is saved as Yolov8n.onyx. So let me show you this file as well. So here we have the .onyx file. You can see over here. So we have successfully converted our model into Onyx format, Yolov8n.onyx file here. Now to do all this in Python instead of command line, I will go to my folder. Okay. So in this folder, I have created a file by the name prediction. I have created a .py file, prediction.py file, which you can see over here. Now I will create a project in PyCharm. Let me open PyCharm. So this I have opened PyCharm. I have created a project, and here I have the prediction.py file. So here I have written the code here. So let me explain you the code. From Analytics import YOLO. Then I have initialized YOLO with the model name. You can see here I have passed the name, my model Yolov8n.pt. You can pass any pre-trained model, or if you have any custom model, you can also add that model over here. Then I am using model.predict. So predict method takes all the parameters of the command line interface. So here I have defined input image1.jpg, save is equal to true. And to save the bounding box coordinates information, I have written save-text is equal to true as well. And I have set the confidence value is equal to 0.5. Now let's run this script using Anaconda prompt. So I have opened Anaconda prompt, and here I will write Python prediction.py and press enter. So now the script will execute, and it might take few seconds. So let's wait and see how our results look. Okay. So it might take few more seconds, so please bear with me. It will not take more than few seconds. So now our results are saved in runs, detect, predict, well, and tables. So let's go towards this folder. Okay, runs, detect, predict 12, and here you can see the output image. Let me show you this image as well. So just opening the image, and so this is our output image, which you can see over here. The detections look very fine. So plus we can also see our in the labels folder, my bounding box in this text file, my bounding box coordinates are saved. So you can check it as well. Now we will see how we can convert our Yolov8 model into an Onyx format. So let me show you this as well. To convert model in O&X format, just comment out this line and write model.export format is equal to just similar and O&X. Now just save it and just open Anaconda prompt and write Python prediction.py and just press enter and see whether our model is converted into Onyx format or not. So we can see that our model Yolov8 is successfully converted into Onyx format. Let me show you the Onyx file as well. So if we go over here, this is the Yolov8n.onyx Onyx file. So we have converted our model, Yolov8 model, into Onyx format. In this video tutorial, we have implemented object segmentation and detection using Yolov8. In the next video tutorial, we will run Yolov8 in Google Colab. See you all in the next video tutorial. Till then, bye-bye.